Hello everybody and welcome back to the Flourish Field YouTube channel. Today we continue our series on algorithms and we'll be talking about the insertion sort. This algorithm is used for sorting data in ascending order. We will do ascending order, and this sorting algorithm work much like the linear search algorithm in that it goes through a set of data in a linear pattern. I'd like to use an example to demonstrate the insertion sort. Say we have some numbers. We have 7, we have 1, we have 2, and we have 5. Now, to sort this in ascending order, you understand that 1, the order we should have should be 1, 2, 5, and 7. To get to this, what the insertion algorithm does is it picks this value. Let's call this value the key, and then it compares it with the value behind. Once it does that, if this value is less, that is the value behind less than the key, they will swap places. So what we will then have is 1 and 7. We have 1, pardon me, we have 1, and then we'll have 7, and we'll still have 2 and 5. But then our sorting is incomplete. The key moves one place forward. The key moves one place forward right there. And then it checks again, compares which is bigger. Okay. If this is greater, they swap places and this moves back. Okay, so then we would have 1, 2, 1, 2, 7, and 5. So as you would guess, 5 becomes our new key and 7 becomes the number behind. So it goes again, checks if this number behind is less, let them swap places. So they swap and would have the last set of data right there. So let's make this out into code. Let me rub off the screen, clear up all the numbers. I always like using random numbers. So let's create our set of random numbers first. So I go import random, and we create a set of random numbers for I in range. I like to use 10 numbers this time around. So I like 10 numbers. Then I go, so each number is n equals random dot rand int rand range. I want any number in the range 1 to any number in the range 1 to 20, and then I append to a list. Oh, I should have created an empty list. So I'm calling my empty list numbers, which is my empty list right there. So I append each number generated to the list. Append n. So I'll just go right ahead and print my random list of numbers. So I go ahead and print this. Print numbers. Let's see. Yeah, there we have it. So we have our list of random numbers right there. We have 10 of them as I wanted to create. Now we can create the algorithm. Since we have the data we would like to sort, we know that our random numbers are available. So the first thing we want to do is to create a loop. So a for loop, because we know we will be looping 9 times for 10 numbers. So we go for I in range 1 to the length of numbers. Good. Now after creating our for loop, we want to create our key as a variable. So key equals numbers at I starts as 1, so numbers at I. But we also want to create the number behind. So the number behind would be, let's just call it back. Let's call the number behind back. So I go back equals I take away 1. So this gives us the position behind. That gives us the position behind. So now for the swapping, the comparing and the swapping. To do this, we want to create a while loop. A while loop that is a loop that runs until a condition is met. So we want to loop through the set of numbers that we are comparing until every number behind is lesser than the key. That is what we want to do. So we go while back, the back number is greater than or equal to 0, and our key is less than whatever number we have at whatever number or value we have at back. We have at back, and the key is lesser than the number we have at the back. So if that happens, we want to swap. If this happens, of course we want to swap. We want to swap the key with the number behind. If the key is lesser, we want to swap. Excuse me. So we go, our numbers takes the position of back plus 1, and that equals the last position we were at, which is numbers at the back. Excuse me. Numbers at the back. Sorry. So after doing this, we want to decrease the value of back, because back, as the key increases, we want to ensure that the number at the back as well is retained as the number behind. In that when key is 2 now, we want back to be 1. When key is 3, we want back to be 2. So at every time, we want back to become less. So we go back minus, we decrement back minus equals 1. And in the loop, every time we want the positions to increase. So we go numbers after setting the number behind, we surely want to ensure that our key increases in position. So we go back plus 1 is now our key. So let's go ahead and see how this works for us. So I'm just going to go ahead and print numbers now. So let me run this. Good. So we have the first set of numbers generated, and we have the second one sorted right there. So this is how to implement a simple insertion sort algorithm. And if you have any comments or concerns, please drop them in the comment box below. Otherwise, see you in the next video.